For Chapter 8, Day 9, we're going to talk about graphing tangent and reciprocal trig functions a little bit further and just go through some more examples. For number 1, you notice we have a cotangent graph. So immediately remember that our period of a cotangent graph would be pi and not pi over 2. So in order to find the period, we're going to go ahead and just state that the period is pi because there is no b value on the inside, which means 4 tick marks out would be pi. That would be 1 period out. And then cut it in half, you get pi over 2. Half of that would be pi over 4. And then 3 pi over 4 could be that third tick mark. Now notice from our original graph for cotangent of x, it has been shifted to the right pi over 6. We're going to deal with that in a minute. But what we should be doing first is actually graphing just the cotangent of x graph. Then we'll apply the transformations. So remember, cotangent of x, there is an asymptote on the y-axis. There's an asymptote at pi. And then the cotangent graph is up at 1. And at -1, we start high, go through at pi over 2, end low. So this, again, is the graph of cotangent of x. So if you're going to draw that graph, I recommend it. And then you can apply your transformations to each point within that graph. But I would make it dotted so that it's clear that that is not part of your actual graph because that is just cotangent of x. Now what we want to do is apply the transformation to this graph. We notice that opposite inside, this is a phase shift right, pi over 6 units. So what we're going to do here is we're going to take each point and we're going to move it pi over 6 units. So this one's got to go right pi over 6 units, which isn't quite pi over 4. So it's going to be about here. We're going to move this right pi over 6 units, and we're going to move this right pi over 6 units as well. Okay? So when we do this, we notice that this, because that's the only transformation to our graph, this blue line would actually be the graph of cotangent of x minus pi over 6. Now remember, there are still asymptotes, so these asymptotes actually move over pi over 6 as well. So this would be at 7 pi over 6. So if we want to get rid of all this mess here, these asymptotes, notice that our new graph now has the asymptotes at pi over 6 and 7 pi over 6. So when we go fill that in, we can fill that one in right away. X equals pi over 6 and x equals 7 pi over 6. Those are the asymptotes, again, only for this one phase, one period, because again, if you continue on, it does go on left and right forever. Notice for our x-intercepts, where we started at pi over 2, we added pi over 6, so that would be 3 pi over 6. 3 pi over 6 was the initial, plus the pi over 6, because that was our phase shift. You get 4 pi over 6, which means that our x-intercept is now at 2 pi over 3, comma 0. The y-intercept, if we notice, we don't show that phase, right? We don't show that period. So if we want to find the y-intercept, we can do it algebraically. Remember, for the y-intercept, set x equal to 0 and solve. So if we did that, you would have y equals cotangent of 0 minus pi over 6. So cotangent of negative pi over 6. If we drew that on the unit circle, that would be right here, where you're at root 3 over 2, comma negative 1/2. So then cotangent x over y would be root 3 over 2 divided by negative 1/2, which would just be negative root 3. So the y-intercept would be negative root 3, comma 0. So algebraically, that wouldn't be significantly easier because those numbers don't work out nicely on our graph, especially when we're not actually showing that period on our graph. Okay, so again, to graph these, you're going to notice we're taking our base functions. That's what we did on the warm-ups yesterday, applying the transformations, and then from there we can identify the period, the x-intercepts, y-intercepts, asymptotes, and all that stuff. On number 2, we're going to take a look at cosecant. Well, remember, cosecant is the reciprocal of sine. So we're going to graph originally sine of x minus pi over 6. And if we graph that, the b value is again 1. So the period is going to be 2 pi over b, which is 1, so 2 pi. The period of sine is going to match the period of the cosecant. So if we graph sine of x minus pi over 6, the period is 4 tick marks out. We would normally start at the origin, go up to 1, go down to -1. But again, because we have this phase shift right pi over 6, we need to take those and shift them pi over 6 units as well. So we would start here. We would move up. And then we would come back down through the origin, the central point, bottom out at -1, and then back up again over here. So if you notice, there's a lot of shifting and transforming going on here, but we've graphed sine of x minus pi over 6 by taking the original sine of x graph and shifting it right pi over 6. Okay? Now, what we want to do, again, is we note that for cosecant, anywhere there is an x-intercept on the sine function, that would be an asymptote on the cosecant function. And then anywhere there's a max or a min, that is our max or min flipped outward on our cosecant graph. So that's the general graph of cosecant of x minus pi over 6. We note that, again, if we get rid of the purple, the blue represents our cosecant graph, so there are no x-intercepts because those are asymptotes, and our blue graph never comes anywhere near the x-axis. For the y-intercepts, we can do the same where, again, we take the x value equal to 0. So y equals cosecant of 0 minus pi over 6. So the cosecant value of, again, negative pi over 6, where on our unit circle we said was root 3 over 2, negative 1/2. Well, we know that sine of negative pi over 6 is negative 1/2. Therefore, that would be -2 for the cosecant because it's the reciprocal trig function. So we would have the y-intercept being 0, -2. For the asymptotes, we saw the shift. Remember that the x-intercepts of the sine function, so x equals pi over 6, x equals pi plus pi over 6, because we shifted that right, pi over 6, so you would get 7 pi over 6 would be the second one. And then the same thing with 2 pi, so you would get x equals 13 pi over 6. If you take the 2 pi and you add pi over 6, that would be 12 pi over 6 plus pi over 6 is 13 pi over 6. For number 3, very similar traits, but now again, we take a look. For secant, we want to first draw the cosine of x plus 1 graph, where again, the b value is 1, so the period is going to be 2 pi. So 4 tick marks out, we're going to have 2 pi. But note that for this one, we are going left 1 unit. Not 1 tick mark, but rather 1 unit. So we have 2 pi, pi over 2, 3 pi over 2. And if we take our normal cosine graph, which if we draw that normal cosine graph, it would look something like this. If we take that away and we shift it left by 1 unit, well, this is normally pi over 2, right? But pi over 2 is, if 3.14 is pi, then pi over 2 would be roughly 1.56 something. If we go left 1 unit, we're going to be just short of that tick mark. So notice how vertically we are just short of that 1 tick mark. So that would be this moving to the left. Now again, this would move to the left just under a tick mark. This would move to the left just under a tick mark, and so on. So if we graph this one, this again is just the cosine graph of x plus 1. But recall that the secant graph is very similar again to cosecant, where the x-intercepts are your vertical asymptotes. And then the maxes and mins represent the maxes and mins of your secant graph. So as with the cosecant graph, notice that there are no x-intercepts because the blue graph doesn't come anywhere near the x-axis, because those intercepts for the cosine graph are vertical asymptotes. If we take a look for the y-intercept, same as the other one, we want to plug in 0 for x. So we have y equals secant of 0 plus 1. Well, the secant of 1 is not on our unit circle, so we're just going to say that the y-intercept is at 0 comma secant of 1. If it was asking for an approximation, you can plug it in your calculator. The asymptotes here, we can see them vertically, but again, the way we found them is we took pi over 2 and we went left 1 unit. We took 3 pi over 2 and we went left 1 unit. So the asymptotes are going to be x equals pi over 2 minus 1, and 3 pi over 2 minus 1 as well. So the best way, again, to find the secant and cosecant graph, rather than memorizing those base functions, is to, again, transform the sine and cosine graph first, and then use the x-intercepts and the max and mins to determine the asymptotes, and then the max and mins for those secant and cosecant graphs. The last one we're going to do here is up on the back page. It says same thing. The only thing you got to be careful with here now is notice we do have a b value. You first, just like we did sine and cosine, you first need to factor out that b value, which is not b, it's actually 3. Factor out that b value, which is 3, and then don't forget to factor out that c value that's on the inside. So you have 3 times x plus pi over 6. With this information, note that 1 period of the cosine would be 2 pi over 3. So that would match for the secant, which means 4 tick marks out is 2 pi over 3. Half of that would be 2 pi over 6, which would be pi over 3. And then half of that would be pi over 6. Okay. That would be pi over 2, because pi over 3 plus pi over 6, since that is our scale, would be 3 pi over 6, which is pi over 2. From there, again, our cosine graph, there's no vertical stretch, there's no amplitude here, it's just 1. So for cosine graph, we start high. This would be the normal cosine of x graph. But again, we are going left pi over 6. So all of these have to shift 1 tick mark because that's our scale. Luckily, our scale is going up and down by pi over 6 on the x-axis. So this is going to shift left 1, left 1, left 1, left 1, and left 1 tick mark. So if we get rid of that cosine graph now we have cosine of 3 times x minus pi over 6. After that, it's the exact same it was on the last problem. Our vertical asymptotes are made by the x-intercepts for the cosine graph. The maxes and mins create the maxes and mins for our secant graph. Intercepts, there are none on either, notice, because again, there are no x-intercepts, but notice that by shifting, our vertical asymptote has now landed on the y-axis, so there are no x-intercepts, and the asymptotes for one face would be 0 and pi over 3. So you can see the connection, again, that the reciprocal trig functions have with the sine and cosine periodic functions. You want to make sure that you're confident and able to graph those with all those transformations, because after you graph them, it's just a matter of finding the intercepts to turn into asymptotes and the max and mins to flip outward. Okay? Go ahead and try the homework. If you have any questions, ask your teacher.